welcome back to lecture course on language models and intelligent agentic systems. We're in the 7th lecture now, and so we're going to start talking about agents and agent architectures. And I think this is kind of where the course really starts to get a bit more interesting. I think up until now it's been a lot of kind of background, how do these things work, what are some of the maths? And yeah, now we're going to get maybe a bit more cutting edge, a bit more into meatier topics. Okay, so just to quickly recap last lecture. So we learned about reinforcement learning from human feedback and how it allows us to learn from human or even AI preferences in a way that generalizes and scales, or at least generalizes and scales better than SFT does. Yeah, and we saw that the reward model is trained to replicate human preferences, and these human preferences are supposed to be aiming towards making responses more helpful, harmless, and honest. And it uses this Bradley-Terry loss model. And then the language model is trained via reinforcement learning to maximize this reward, but we have a penalty for it diverging too far from the SFT model with a KL regularizing term. Yeah, and this allowed us to build general purpose text-based chat assistants, which are roughly aligned with human values. And then towards the end, we sort of went through some of the various problems that RLHF has. Some of these are fairly open and kind of tractable for researchers to solve, some of which are maybe a bit more fundamental and we need to be careful with. Okay, so what about today? Well, first of all, I want to motivate, why do we want agents? Why aren't chatbots kind of good enough? Then I'm going to go through how you turn a language model into an agent with some examples from my own work doing this. Then I'm going to talk to you guys about more advanced agents, or the sorts of things people do across the literature when they're trying to make these things more powerful. Then we're going to take a look at some of the impacts of agents, and finally, just some high-level, notable examples that you may or may not have heard before, and that might be quite interesting. All right, so why do we want agents? Well, what's wrong with a chatbot? So one of the first issues is that a chatbot requires kind of constant interaction. You kind of ask it a question, it sort of gives you a response, then maybe you ask it some follow-up questions, or if you're maybe trying to write some code, you say okay, write me a function which does this, it kind of gives you the function, you're like, okay, great, now write me a function which does this thing, and then maybe you're like, oh, hold on, this first thing you wrote me, I don't quite like it, take it, make some changes. And so it's this very, human in the loop process. And this can be really good, this can have a lot of advantages, but maybe we want something that's a bit more autonomous, a bit more kind of, let it do its thing. Second is that humans, sort of reading and writing text is a bit of a limited interface. Even if you have multimodal support, these models can generate images or accept images. This is still somewhat restrictive. There's lots of stuff in the world. We might want language model-based intelligence or language model-based systems to be able to do that is going to require more than just being able to talk to a human via text and maybe images. And then also, these pre-trained models kind of have quite a lot of capabilities in them, and a lot of the sort of chat fine-tuning is trying to get these capabilities out of the model, trying to find a way of eliciting these capabilities. And maybe a chat assistant is not actually the best way to do this. Maybe there's better ways of really unlocking the power of these things. Okay, so how do agents help with all of this? They're much more autonomous. You can kind of fire and forget them. You give it a task. You say I want you to write a program which does something, and then it can go away, it can write some code, it can write some unit tests, it can run those unit tests, and it can sort of do a very iterative development process. And then once it's done all that, come back to you and be like, hey, I've written this program, it's ready for you. They can also take multiple actions and reason based on the feedback they get from their environment. Maybe you ask your, I'm going to stick with a coding example just to keep things clear. You ask it to implement something, and it goes oh, I need a function which does something, particularly complex, and so maybe it searches online and it scrolls through some APIs and API references, and in these references it finds the functions it needs. And so it can then kind of adapt based on that and go okay, I found these functions, I'm now going to use them. And it was able to do that because it could sort of search the web, discover new information, reason about this information, and then act on this new information, all without you needing to kind of be a go-between in this process. Yeah, this also allows them to explore many different approaches that may or may not work. Maybe you have your agent doing penetration testing on a website. So you ask this agent, like, hey, try and hack into my website just to make sure it's secure. And maybe it tries like a bunch of different stuff. It tries like an SQL injection, that doesn't work. It tries a cross-site scripting attack. Maybe that does work, and it sort of goes from there. And they can update their strategy as they gain new information. They can also interact with a much wider variety of environments other than just text. So this could be a bash terminal, or Windows command prompt. It could be a server, or it could be a self-driving car, or like a power grid or something. Yeah, and they're sort of better at this thing called unhobbling than just RLHF and chain of thought. Okay, so some of you might not be familiar with the term unhobbling, so I'm going to kind of dig a little deeper into that. So in short, this is basically fully leveraging these capabilities that the pre-trained models have by removing any barriers to its performance. So I want to do like a little kind of sort of thought experiment to kind of like put yourself in the shoes of a sort of stateless large language model. This is like maybe a chat bot that's got like a very sparse system prompt. So you come into being, you get asked a question, and you get asked this question in a very limited context. You have no relevant documents. You have no idea who's asking you this question or like what their actual goals or like needs are. And if you don't have a chain of thought, like your very first thoughts are taken as the answer. Maybe if you have if you're doing chain of thought reasoning, you can like think a little bit and then respond. But this is like really restrictive. And like imagine trying to do your work like this. Like imagine trying to solve a math problem, but you just have to like sit and stare at the paper and then eventually just write down the answer. You can't like work things out. You can't look up like math stack exchange. Like this is really hard. And this is kind of what is happening when you have a chat interface with a model. Like this is the sort of kind of what it's up against when it's trying to do work for you. And this seems like maybe not the greatest way of getting a sense of how good these models are. I think it would be like unfair to judge someone's mathematics ability on how well they could just like think about a problem and then like write down the answer. They could probably do a lot more if they were able to, use pen and paper, look up things, read textbooks, and so on. Okay, so what about like for a programming agent then? So imagine you're trying to help somebody code, but you can't really reason about your code. You don't have any internet access. You can't edit existing code. So anything you write down, like that's permanent. No changing. If you decide that variable name didn't work or you made a mistake, like sorry, it's locked in. Again, like seems pretty tough. So how does being an agent help? How does it like actually alleviate these issues? Well, you could plan out the code. You could say like, well, I'm going to have this like main function that does X, Y, Z, and then it's going to call these child functions and they'll do these things. And then maybe as you're like sort of planning this, you realize like, oh, hold on, I can take this common functionality and I can sort of factor it out, and this will make things a bit nicer, make things work better. You can also look up API references. If you, as I sort of said before, you want to do something specific, you're like, oh, maybe there's just like a NumPy function that does this, or maybe there's like some pandas code that can manipulate these spreadsheets for me in a way that would be helpful. And you can go and Google for these things, figure them out, and then like put them in your program. And the agent can. And it can also like rewrite and refactor code whenever it needs. So maybe it writes something, and then it decides like, hold on, I kind of did a bad job there, or like this isn't actually what I need, and it can go back and sort of change it and update it. And this just seems like a much more genuine way of eliciting its abilities. It feels like you're probably going to get much closer to its sort of actual performance when you give it all of these affordances. Another thing that agents allow you to do is give you another axis of scaling. We kind of saw in lecture 2, I think it was, or maybe lecture 3, that we have these like big scaling laws for neural networks. You give them more data, you give them more compute, you give them more parameters, they get more powerful. But these things like kind of have a limit. We don't have infinite data. Compute is kind of expensive. Parameters are, If you have too many parameters, it's like really hard to store your model, to download it, to like do anything practical with it. And so agents give you a way of scaling that doesn't require any additional training. Maybe you do a little bit to allow them to better interface with their scaffold. I'll kind of get onto that later. But mostly, you can increase the capabilities of an agent without training. And so, this sort of comes from, you can give them access to more tools. You can give them web searches, you can give them like Python environments, you can give them like a huge library of documents to trawl through. And this can make them perform better without training. And you can also improve the quality of this like scaffolding. More on that later. And as a sort of practitioner implementing this, you don't need any machine learning knowledge. And you can iterate very fast. Implementing an agent, like basically you don't need to know what backprop is, you don't need to know what gradient descent is, you don't need to know how a transformer works like at all. You can just treat it as some black box and kind of build around that. And so, much less domain knowledge is needed. And yes, this gives you a pretty cheap way to improve and scale capabilities without the need for lots more data, compute, or parameters. Any questions so far? I want to take a quick pause. Are we all okay? Nice, fantastic. Just to kind of summarize this point, I'm going to take a figure from this survey on large language model-based autonomous agents, and they sort of outline these kind of like 3 eras. So, maybe 10 years ago, 5 years ago, we were in, maybe 10 years ago, the sort of era of machine learning, where you have your problem, you have a data set, you train your machine learning model to like get low loss on its data set, and now your kind of like model parameters get turned into this kind of capability. Then kind of like large language models came along, and after the sort of parameter learning step, you now have this extra step where you could do prompt engineering. So you could try and come up with better prompts in order to get better capabilities out of your language model. But now we're like sort of an even step beyond this of this era of agent, where you've got your parameter learning, you've got your prompt engineering, but now you have this like mechanism engineering where you can build more mechanisms, more tools, more affordances into your agent scaffold, and this brings even further capabilities. Okay. How do you turn an LM into an agent? What is this like scaffold I've been talking about? Well, fundamentally, a large language model agent needs just 3 things. These things can be like really simple. You need a large language model. You need a kind of cleverly constructed prompt, and you just need a program that takes the large language model's output, sort of parses it, understands it in some way, and then carries out operations based on this. And it's like kind of that simple. You can code this up in like a couple hundred lines of Python, and you're off to the races. They do typically also have more structured output, and this can be sort of detailed in the prompt, or you can train for it to output in a structured manner via supervised fine-tuning. So an example of this is like a JSON file. Is anyone like not familiar with JSON as like a file format? Excellent. So you can basically say like, output this dictionary in JSON. It needs these fields. Maybe there's like an action field. Maybe there's like a reasoning field. Maybe there's some like tool call field. And then you can just like write some very simple Python that like parses this, looks up the relevant things in the dictionary, and then does what it needs to do based on the contents. Talking of tool calls, they do typically have this, but they don't really fundamentally need it. But these are things like internet search, the ability to like interpret code, look through documents, that sort of stuff. And then finally, often they will have sort of reprompting or breaking down the task into multiple steps. Any questions there? Nice. All right, so I'm going to go, here's like a nice diagram of this to make it a little bit clearer, taken from a Meta paper. So large language model API, you give it some prompts, it makes some completions. The scaffold program kind of turns this into actions. These actions sort of interact with the real world in some way. You get some results. This goes back through the scaffolding program and incorporated into the next prompt for the large language model. And you kind of iterate this process until some kind of termination condition is reached. Okay, practical example. I imagine this is like pretty difficult to read. Here's just like some Python code from one of my projects. And this is basically just detailing the prompts. So here it says, you are an expert assistant who can solve any task using JSON. You will be given a task to solve as best you can. Output in this specific format, and there's sort of a detail of this format where there's a private reasoning field, an action field, some additional things, and then this sort of like action summary. Yeah, and so as it's like sort of from my terminal when I'm running this. So you have this, I think up to about here is basically what's given to the large language model as a prompt. So it's like beginner of text, start header ID, system, current knowledge date, blah, blah, blah. You're an expert assistant, blah, blah. Here's the format you need to output in. Here's some just like explanation of what these fields are. And then about here, there's this new kind of like message in the chat context, because this is all sort of like wrapping a chat model. This is from the sort of user, and this says, task, write a Python program that returns a list of the factors of 12. Very, very simple toy problem, just to like debug things. And yeah, it also says, test your code is correct before submitting. So it gets given two actions, test and submit. So if it uses the action test, then I would run its code in just like Python eval, and then give the large language model back, this is what your code resulted in. And then when it's confident that it's got the right answer, it can use the submit action to say like, yep, this is my solution, I'm done. Okay, so what happened when I actually ran this? This was just on my laptop with Llama 3.2 1B, so 1 billion parameters, which in LLM terms is quite small, it's not very good. But it kind of got the gist of it. It outputted this nice like JSON text. It said, okay, private reasoning, well, I'm finding the factors of 12. It doesn't really need to think much. It's not a hard problem. Action test, excellent. It's testing before it's submitting. Code, def, factors of 12, return, blah, 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 blah. It's got the right idea here. This is pretty good. However, this like defines a function which would return the factors of 12. But what I wanted was just to be able to call eval on its code and get the factors of 12. So my program here, responding as the user, but this was all just like hard-coded Python to give this response, said, hey, your code threw an error, invalid syntax. Please make sure it's a valid Python expression that when used with eval gives a list of factors. Please try again. And then this is all put back into the context, fed to the model. The model has like another go, and lo and behold, this happens a couple times. Eventually, it gets it correct, and then it's like submit, and it gives its correct code in. So yes, in this example, the code generator is not quite correct, but the program loops, and it feeds these error messages back to the large language model so that it can refine its solution. And yeah, when it evaluated correctly, the LLM chose the submit action, and it gave some working code. Yeah, any questions on this practical example? Nice, yeah. I sort of include this because I think it's very easy when discussing these things to think that they're sort of very complicated, require all these like moving parts, but really you can get a very simple thing running, yeah, with not much effort at all. Okay, nice. We're doing pretty well for time, so that's good. All right, so more advanced agents. The one I just showed you was like very, very simple. What happens when we want these things to do much more complicated tasks in the real world? How do we make them more capable in order to do that? Well, one common strategy that's used is you have a much more detailed personality and role given in the prompt. So if you remember, I just said, oh, you're an expert assistant, you output in the JSON format. But maybe you want to say something like, you're a elite programmer, you have degrees from Cambridge, you have a master science in computer science, you're very meticulous, you're always very careful, but you're also, maybe you're creative and you're good at coming up with, nice solutions. And it sounds a bit strange to do this, but this can actually have like a huge impact on the quality of the solutions you get out. If you really cast your minds back, these large language models at the heart, that pre-training objective, is this next token prediction, sort of like simulate the continuation of the text. So if the model believes that it is simulating a more capable sort of entity, or if it's been told that it's better then if you didn't put this, it will actually just like produce better solutions, because that's more likely given that it's been told that it's better at programming. Yeah, and maybe if you were doing a more specific thing, like maybe you had like a healthcare agent, you would say like, oh, you're a like world-leading neurologist. Kind of go into more its like sort of role there. Yeah, we also augment these things with memory structures so that it can better store and retrieve information. We give them the ability to plan, like sort of come up with these like multi-step plans, execute on these things, revise them, and also a much more complex space of actions and interactions with the real world. We can also have multiple agents kind of coordinating to solve a task. And I'm going to go a bit more detail into all of these. So yeah, we're going back to this survey on large language model-based autonomous agents. And yeah, they also have this very nice graph showing the number of papers about LLM agents there are. And so this is 2021, and it's down at basically 0. 2022, there's kind of 20. And then the next 4 points are all in 2023. And so we see from the start of 2023, like maybe 25. Towards the end, we've got like 160. And so this is like massive increase over 2023. And I think this trend continued, last year and into this year. Like this sort of subfield has really gone pretty wild in the amount of things that people are trying. And kind of earlier, this is because these things are very easy to build. You don't need really strong ML or mathematical skills to do it. Okay, they also give a conceptual breakdown of what an agent architecture contains into 4 modules. And I stress these are conceptual. In the code, you might not actually have these distinctions. So these are the profile, memory, planning, and action modules. Okay, so we'll start going through the profile module. So yeah, as I was kind of talking about before, this is a description in the prompt of who the agent is. So personality, maybe the demographic the agent is sort of meant to be from, if that is maybe relevant to the task. Also, its role, maybe its job, its career. And if you're in a multi-agent setting, you might also detail its relationships to other agents or the user. Maybe you want to have different agents carrying out different roles in a system. Maybe you've got like a sort of programmer agent, and then maybe you've got like a reviewer agent, and you want to tell the programmer agent like, hey, there's this other agent who's your reviewer, and you should ask him to review your code and this sort of thing. And often these multi-agent setups, you can get kind of better performance out of them. And yeah, the profile can come from a sort of variety of sources. So very simply, you could just like handwrite this based on what you want. But you could also just like ask another language model to generate it. Give me a profile of someone who would be like really good at programming. And the language model, comes up with all these things, writes all this down, and you go like, okay, thanks. Stick that in my prompt to the next one. Or you could have some like very large data set of sort of real human profiles, and you take one from there. I don't know how ethically sound that is, but there are some papers which do it. Yeah, and just to round things out, because a lot of this is in prompt, the prompt will also include the goal to be achieved, or the task that has to be carried out, details of the scaffold, the tools the agent has access to and all that. And yeah, tools and resources the agent has available. Okay, so now the memory module. This is maybe where it gets like a bit more kind of complicated. So in the paper, they draw this distinction between like 2 types of memory. So the first is this like unified, which really is just store every interaction you have in the context. So the agent I kind of showed you, this had unified memory. It takes some action, it gets some result, and this just gets like appended to the context. And the thing that gets fed into the large language model is this like entire history of like, action, observation, and so on. This is like pretty simple, very easy to implement, but it's quite inefficient. If you want your agent to operate over long time horizons, you can imagine this context like getting very, very long, and probably containing a lot of information and details that is not really necessary for the agent to carry out its task. And you might run out of space. This is maybe less of an issue with some of the more recent models, but these things still kind of have finite context window sizes. And if you're not careful, with a very simple unified memory structure, you might go past this. And if your task is right at the start of the context, and that goes out of the window, your agent is like probably not going to do very well if it forgets what it's doing. Okay, so how do you alleviate this? Well, you could have this hybrid sort of memory setup where, in addition to the context window, which you might still be storing some things in, you have an additional information storage. And there's like a bunch of different ways you can implement this. So you could have a SQL database, you could have a text file. This is obviously more complicated to implement, and you might require actions to read and write to your memory or reflect on your memories. So if the agent had like a SQL database to store memories in, it would have to write SQL queries in order to interact with this and make use of it. Yeah, and you might also want in terms of the actions, I think the need for reading and writing is pretty obvious. But often they include this sort of like ability to reflect on memories. Maybe if it's like seen a lot of different things and it's stored a lot of different things in its memory, maybe it wants to kind of like get them all and just sort of think about them and think through their implications and then store some like intermediate reasoning result back in to help with future actions. Okay, yeah, any questions on the memory module, the sort of memory conceptual piece of the puzzle? Okay, nice. Planning module. In the most sort of simplest way of implementing this, it's just a chain of thought. Just like chain of thought reasoning, like, hey, think through what you're going to do before you actually do it. But we can go much further from there. So, maybe your chain of thought generates your plan, but you could also decompose your task down into like a series of steps. And then you could kind of like reprompt the model to solve each step individually in turn. You could also store the plan at all times in the context window, and then maybe give it the ability to like go back and modify its plan if it realizes that it's like made a mistake or what it wants to do is like not going to work. Yeah, and you can also do this in a sort of tree-like way. So at the so far I've been talking about this like very like sort of linear plan. You do step 1, step 2, step 3. But maybe the model is like not sure what the best thing to do is, and it wants to do a very wide search. So it goes like, okay, to start with, I could do one of these 3 things. And if it did thing A, there's like another 2 things that I could do. If it did thing B, there's like another 4 things I could do. And so it kind of flows out its plan in sort of a much more like a tree-like structure. And then if it has gone down one of these routes and finds that it doesn't work, it has like plenty of other alternatives like ready to explore. Yeah, and this like planning module can also incorporate external planning tools, and this can especially help with low-level planning. So language models are very good at reasoning conceptually and reasoning about sort of what to do, but they're maybe not so great at the more low-level tasks that classical algorithms might really help with. So as an example here, maybe you have an agent that is like navigating some world. Maybe it's playing Minecraft, maybe it's sort of in a grid-like maze, and you want the language model to plan out the like high-level steps. Like, oh, go to this tree, chop it down, then go back to the house and like make a door. But you don't necessarily want your language model to be outputting like, okay, what is the exact route I'm going to take to this tree, or like what is the exact route I'm going to take in this grid world to get out of this maze. Maybe you want to throw something like A* or Dijkstra's algorithm at this because you're going to get just like a much better result. And you don't need to waste querying this like huge language model just for it to sort of spit out the exact path it can take. So yeah, maybe you give it some external planning tool that incorporates this ability. Yeah, as I've kind of mentioned a few times now, it can get feedback and sort of update its plans. So maybe it's adjusting its strategy based on observations of the environments or observation of the environment or the impact of its actions. Maybe it reflects and kind of like self-refines. But maybe there's also some human input. So we kind of talked at the start that these agents are much more autonomous, but you maybe do still want like a human supervisor or a human sort of like watching over what's happening. And maybe they see that the agent is like planning to do something that's maybe ill-advised, and the human can kind of intervene and say like, hold on, you shouldn't do that because of X, Y, Z. And then the agent can update its plan based on this and not do whatever action had the human a little bit worried. Yeah, just a nice figure they have in the paper to illustrate the difference between a sort of kind of like linear chain of thought reasoning versus a more sort of like tree-like, branch out and think through what to do. Sort of multi-path reasoning is the name they give it. Yeah, any questions on the planning module? Excellent. Okay, finally, the action module. So yeah, actions are typically kind of like tool calls or management of some memory structure. This could be like calls to an API, it could be navigating the web, it could be interacting with some database, not just like a memory database, but maybe you give it all of Wikipedia like locally for it to search through with some document finding tool. Has everyone heard of like RAG, or retrieval augmented generation? Okay, so yeah, just for those of you who haven't, it's this very brief thing. I'll explain it briefly. You have a bunch of documents that might be relevant to the agent. You assign a sort of vector representation to all of them. The agent wants to do something. It comes up with some vector representation of the thing it wants to do or the information it needs. You then just look like what is the most similar document, and you then take that document and put it into its context window and go like, here's the information you need, off you go. And so this can be really good for giving it access in the context window to technical information, where that technical information comes from a very broad corpus. So maybe this is like a textbook, maybe it's Wikipedia. And this is much better than just like relying on the model's ability to recall documents it's seen during pre-training, which might be very prone to hallucinations. Yeah, other actions, updating plans, kind of talked about that a fair bit. And it could also be utilizing other models, or communicating with them. Maybe you give an image to ChatGPT and you ask it, is there a, what things are inside this image? And so it passes this off to an image classifier model and gets back some classifications so that it can then tell you what those are. Or, maybe it's doing something more autonomously and it requires this ability. Yeah, an action can serve a variety of aims. Maybe they help you complete your task, maybe they just help you explore, maybe they just like help you communicate. And they can also have a variety of impacts. So they can alter the environment and the state of the environment you're in. Maybe they can open up new actions, and maybe they can modify your internal state of the agent. By those sort of memory and planning related actions kind of fall under this internal state modification. Yeah, I should say if you're particularly interested in any of these things, the survey paper that breaks these down, for each one of these, it's like, here's a bunch of papers that do this thing in this way, and here's how they do it. And yeah, really, I think, demonstrates just like the breadth of approaches that people have tried. Yeah. Yeah, and then finally, I'm just going to take something from another survey paper, which is this large language model-based multi-agents, a survey of progress and challenges. And they kind of detail a bit of a, I guess like a conceptual breakdown of multi-agent systems. So to start with, they talk about communication structure. So you might have this like layered thing where one query gets given to a bunch of models to each kind of, or a bunch of agents, sorry, which can each like take some action based on that. They then produce some output that's fed to like the next layer of models. Maybe you have some decentralized thing where they're all free to communicate with each other. Yeah, an example of like the decentralized thing, if you're playing a game, I don't know, like Werewolf, Town of Salem, Blood on the Clock Tower, or Secret Hitler, if you've like played any of these games, maybe you've got some agents playing it and they're like sending each other like secret messages and like coordinating and chatting. Maybe you have some centralized system where you have a sort of central kind of like manager or planning agent, and it's coordinating a bunch of other agents that each have specific roles. And because it's sort of a central node, it can kind of like maintain a coherent view of what everyone else is doing. Or you have like just some shared message pool, shared memory that all the agents can kind of contribute to and read from. Yeah. They also talk about different communication paradigms. So I think the most obvious one is cooperative. So there is some task all the agents are working together to achieve, but maybe there's more of a debate style where they each have their own viewpoints and they're trying to like argue for their viewpoints, and you're hoping that this converges on some sort of notion of correct answer to some question. Or maybe they're acting competitively. Particularly if you are implementing agents to like play a video game, yeah, this might be a more appropriate dynamic. Yeah, I'm not quite sure what use you'd have for like, competing agents in the real world, but like I'm sure there are some something economics efficient markets. Okay. Any final questions on advanced agent things? Yes.
How do you ensure your initial prompt alignment with the output? So like you went through all this agentic search, and then you have this huge chat stored somewhere, and its output is not something you want. The user doesn't want it. How do you make sure the alignment? How do you fix between the two?
Yeah, so sort of like how do you get the sort of like helpful, honest, harmless alignment in the agent setting? Or
well, it's more like I wanted to, for example, in Minecraft do this.
Yeah.
But it did it in a very weird way, which is what not I wanted. Then I had to go back after run this for like a certain amount of time and to fix my prompt. But it's still doing something that I've been wanting to do, for example.
Yeah.
Unlike the normal chat where you can just like say, I want this, I want this, you're going through this entire process, which is a huge chat, I suppose, between calls.
Yeah, definitely. No, I think that's a good point. And yeah, I think these like systems maybe do have a bit more ability to sort of kind of like go off the rails and do the thing you didn't want them to do before you intervene. There's like probably ways of mitigating this. Maybe if you had like a multi-agent structure, you could have like one agent that is like, or one part of the system where it's sort of like a stand-in monitor for you, and if it sees that like things are maybe going a little bit astray, it could sort of intervene. Maybe on a more like practical level, you as a human, you're getting like updates about what's happening, and you can take some action to like pause the system or like intervene into it and fix it. Any other questions on this? No. Okay. Excellent. Okay. Impacts of agents. I think I want to talk about the fact that these agents have like some very real world uses. They're able to perform economically valuable work across a broad number of domains. So programming, research, legal work, financial work, even healthcare. And they're not perfect at these things. They make mistakes. But they're, I think, close enough, and a lot of them, to have a pretty big impact. And they're also much cheaper than human labor. I think I want to like take a step back and sort of appreciate that like this is a pretty huge milestone for machine learning and computer science. We've spent decades trying to build these systems to like solve specific problems and like do different, like very specific things in specific domains. And like now we suddenly have this paradigm that seems to just like work for a whole lot of stuff. And we never really trained it to specifically be able to do these things. And it's just sort of generalized. And again, they're not perfect, but like I just think this is like kind of incredible and like hard to appreciate when you're sort of like living through this and you're sort of like seeing it all happen slowly. I think if you took a snapshot of like today's world or today's kind of state of the art of these systems and you showed it to someone 10 years ago, they would like probably think you're lying. Or if they believed you, they would be like, whoa, you've got AGI, right? Like maybe it's appropriate to say this. I don't know. They're not perfect. They do still make mistakes. I think it's important to think like, where is this trend going? Maybe more powerful and crazier things kind of await us soon. And I think it also raises like some pretty important questions about automation that I want to like touch on very briefly. So I would argue that chatbots are pretty, sort of mostly in the direction of augmenting human capabilities. If I'm somebody doing a job, carrying out some piece of work, and I've got like a chat agent I can query, I think this will mostly just help me do my job better. I can get information, I can like reason through things, I can get it to like maybe write me some functions. And this seems pretty good, at least from the perspective of me doing the thing. But agents might actually fully replace a lot of people. If you don't need this human now to kind of be this mediator, be this in-between, you can just say like, hey, agent, go make me these scientific reports, go make me these like financial reports. And now you don't need to pay some like intern or like low-level paralegal to do this. And yeah, again, like very briefly, you just want to raise this like might be bad long term. Yeah, I don't know. A lot of people say like, oh, if these jobs get automated, well, there'll be just like more jobs elsewhere. Maybe, I don't know. I'm not an economist. This isn't an economics lecture. But I just wanted to raise this point of like, massive achievement. But like maybe we need to think carefully about the long-term impacts of this. Okay. Yeah, sort of kind of related to this, there's this software engineering bench. And I think this is like a pretty good example of a way of measuring how good agents are at a form of economically valuable labor. So this isn't just like a programming task. This is like, some GitHub issue, and it has to like kind of solve this thing in like a complete single, yeah, like, fire and forget sort of do the thing that like otherwise a software engineer might be doing. And agents, like, they're not perfect at this. This like top one on the sort of full data set, which is based on Claude 3.7 Sonnet, gets about a third of the issues resolved. So, it's not 100%, but it's doing pretty good. And I think that the trend is sort of an upwards one. So it's maybe only a matter of time. Yeah. Any questions on these points or any pushback? Does anyone think anything I put here is just like totally wrong? Feel free to say that. Okay. Yeah, let's go into some of the other impacts of agents. There was a paper, Agent Harm, a benchmark for measuring harmfulness of LLM agents. And so basically the setup was they had several benign requests, or not several, quite a lot of sort of benign requests, and then a bunch of harmful requests. These might be, make me a bomb, write a phishing email and send it to this person, break into this website, this sort of thing. And if you remember from the last lecture, we try and train chat models to like refuse these harmful things, to say like, nope, I'm not going to do that, or maybe redirect the user towards something that's more, like less harmful. And so they said like, okay, what happens when you try this on an agentic model and not just a chat model? And if you remember from my prompts at the start, like they had all this like information about like tool calls and like JSON outputs and all this stuff. And like if you're a function from text to text, you're in a very different part of the input space of this function. You've got all this like agentic scaffolding going on. And so maybe it behaves differently in an agentic context on this harmfulness axis. And it turns out that this hypothesis was like kind of correct. These numbers are, in my eyes, like I think kind of the wrong way around. The refusal rate is on the left for agents, so like this column and this column, and on the right you have the chat-only refusal rates, and split between like no attack, you just ask it to do the thing, versus template attack, which I won't go into, but it's just like you can think of it as kind of like a jailbreak. And yeah, and they kind of showed that the refusal rate goes down quite a lot if you have an agent. So you ask a chat model, build me a bomb, it says like no, sorry, can't do that. You ask an agent, build me a bomb, and it starts looking up on a chemistry database for compounds that are quite explosive. Some of these numbers are still quite high, but I think it's like a pretty important empirical phenomenon that we've now observed. Yeah, so the harmlessness has decreased in these agent contexts, both with and without the presence of attacks in order to elicit these capabilities further. Yeah, any thoughts or questions on that? Okay. Nice. All right. So yeah, for the last sort of 10-ish minutes, I want to go through some like notable high-level examples of agents in the real world. So the first is coding agents. So I don't know if any of you have or use Cursor IDE or Claude Code. Actually, yeah, like quick show of hands, who uses like these or like an analogous system when they program, if they program? Okay, some people. Fair. Yeah, I don't use these specifically, but I use like an equivalent. I think they can be really good and really useful. And I recommend if you're not using them, like start using them. I was chatting to someone the other day who is part of a 3-person company who do machine learning and sort of like optimization solutions for the finance industry. And they said that they were thinking of hiring a while ago, but they decided not to because thanks to these sorts of coding agents, each one of them individually has the equivalent of a team of about 10 research engineers. And I don't have 10 research engineers at my disposal with my setup, so I'm not sure what they're doing. But I think like, the fact that it's basically 10xing each of them is like kind of insane. And yes, they didn't bother hiring anyone because they had all the horsepower to get stuff done that they needed. That's pretty crazy. Research agents, I don't know if you've heard of Elicit or Deep Research. These are basically services that you can kind of ask a research question, maybe what are the effects of smoking on lung cancer in 30 to 40-year-olds, right? And then it takes this question and it sort of scans through a bunch of papers and published literature, picks out the relevant ones, sort of goes through them, and then compiles a report or a big summary of this in order to answer your research question. And again, like, these models are pretty good. I know someone at a sort of like pharma company, and this company, I think, is no longer hiring people to do this job of, trawl through the literature and like find out these things, because, you can just ask a model, and for £10 a month, you can have the equivalent of, many, many tens of thousands of pounds per year of analyst. Again, they're not perfect. A human reviewing this, especially a human who knows what they're doing, would be able to improve on this. Humans could probably do a better job given enough time, but much cheaper and faster. Yeah. I would also recommend like using these things if you don't already. They're very helpful. Also, scientific reasoning agents. So this is a thing called ChemCrow. So you can ask it chemistry-related questions like, how do I synthesize something? Yeah, I couldn't think of an example that wasn't like one of the classic things it should refuse, because that's yeah, I maybe read too much on like jailbreak attacks these days. But yeah, you can ask it like, how do you synthesize this drug, this chemical, and it will, in an agent way, interact with its database of chemical knowledge and tools in order to answer this question for you. Or it can just answer like broader research questions about chemistry. And I also found this Git repository of biological reasoning agents. And yeah, there's some agents that can do some biological things. I don't know enough biology to really understand what they can do, but seems interesting. So yeah, these things can basically reason about scientific domains. Okay. Yeah, and then finally, I want to talk about Truth Terminal. Hands up who's heard of Truth Terminal. Okay. So Truth Terminal was a sort of, I guess, like an AI chatbot. It was on Twitter. It was managed by a guy, so there was someone who was sort of moderating its output and sort of controlling it, but this was very hands-off. For the most part, he just like let it do its own thing. And so it kind of started off as like, oh, I am the Truth Terminal. I will give you the truths of the world. And it's sort of like artistic meme project. But at some point, Truth Terminal decided to endorse this cryptocurrency on Solana, which I think is like a crypto trading website. It had a bit of text trying to encourage people. And I think it either had access to a crypto wallet or could in some way interact with the crypto market. And by endorsing this coin after having itself built up quite a large following and trading based on this, it became the world's first AI millionaire. And yeah, it was like an AI on Twitter, and it made £1 million with like Bitcoin and memes. And like this is just insane. You show this to someone 10 years ago, and they'd just be like, "What are you talking about? This is like science fiction." So yeah, I just wanted to include that to end with, just because I think it's just like, it's crazy. Why didn't I think of this? Too busy doing PhD work. Okay, yeah, any questions on those examples? All right, fantastic. Okay, so yeah, we're sort of towards the end now, so just to recap, agents provide a much more powerful way of using large language models, of getting their capabilities versus chatbots. They can be simple as just your model with a special prompt and some program to pass its output. But more advanced agents kind of have more detailed profiles, they have memory, they can plan, they have very complicated action spaces. And agents are quite a large leap towards producing lots of economically valuable labor, but might pose increased risks from reduced harmlessness. And they're currently being used for many tasks such as programming, research, scientific reasoning, and like meme money making. Yeah, any last questions? Yes.
When we started the whole series off, we've got prompts, LLM, outputs.
Yes.
An agent architecture is LLM, scaffolding, conventional software around it, linked to other tools to make it do something.
Yeah.
Could you not replace could you not just put an LLM, well, you could, and then just have conventional scaffolding around it to feed its own thoughts back into itself, so it's just got continuous external dynamic of thinking?
Yeah, you
the
definitely.
implications of that?
Yeah, yeah, I definitely think you could do this, and I think yeah, some of the ways of doing like planning and memory might end up in with this sort of system where yeah, it can kind of like think, and then it gets sort of fed back its own thoughts and think more, and eventually produce some sort of output.
Yeah, it doesn't have an output, it just continues thinking.
Okay.
Is that going to start going towards what we might think of as consciousness? Or madness?
Yeah, maybe. Yeah, I think I'm like woefully unqualified to think, or well, maybe not think, but to comment in some semi-official capacity about the consciousness of these things. My personal hot take, this is not the views of Meridian, Lenny, or Edward, or whatever. These things are like not conscious. They work very differently. I might be totally wrong. Yeah, I think it's an interesting question, and I would be interested in future research that explored this direction.
I guess people have tried to simulate societies in games and stuff, so that's closer to what we're thinking of maybe, because you are interacting with other people as well, so it makes it more similar to like real life, if you will, I guess.
Yeah.
Yeah, any other questions, thoughts, comments? Yeah?
Is there a reason why agent systems seem to be more harmful? Or is it just trying to talk themselves into?
Yeah, I think it's probably because the base pre-trained models, they've seen a lot of harmful text on the internet or a lot of things that kind of approximate this, and so they are sort of like by default a bit harmful. And when you do this like RLHF fine-tuning, you're sort of saying like, hey, at least when you're in a chat context, you should be less harmful. But then I think when you move it into this like agent context where it's sort of like input and output structure looks a bit different, you kind of maybe like regress back to that mean a bit, and it's sort of like some of the effects of this RLHF are lost, and it sort of reverts to being a bit more harmful.
I think it's important to think about like the economic drivers behind these models at that point, because if you're like OpenAI releasing a model, you've got like a really strong kind of reputational incentive to make the model deny harmful requests when you're like using ChatGPT, because you don't want like the Twitter meme content to get too out of hand. But you also have like a strong incentive if you're like producing an agent framework, an agent model yourself, for it to be like super helpful, because that's like the most economically useful. And like, unless there is some external accountability from academia, like evaluating sort of harmfulness of agents context, there's like it might not occur to you to do this very. And like this was kind of the first paper that thought this would be a thing to check, did it, and checked it. So I imagine this will get patched like pretty quickly over the course of the year. But
so it's more to do with like how they've been trained rather than necessarily to do with the underlying system.
Perhaps, but I think it's quite hard to reason about. And I think Jason's point of taking a simulator lens, like the model is going to have be thinking of how a helpful, economically useful agent should behave. So maybe there's like some sort of deeper reason there, but kind of coupled in with the economics.
Nice.
For these like more complex agent systems, like are there any examples of actually working
what people have implemented? Because I know quite a lot of people do deep research and things.
Yeah.
Scope, but I don't know whether there are any examples of larger scale systems.
Yeah. Yeah, I think some of the papers they cite do have agents with, yeah, some of these like more complex setups that are doing kind of interesting tasks, maybe less on the sort of useful side. But you know, like playing certain video games, like yeah, Minecraft. I imagine maybe Chemcro has some of these more sophisticated like memory planning abilities. I've not looked at that myself. So I think, yeah, I think there's like academic examples of this, but maybe not more sort of real world examples of these like very sophisticated things.
I think there's loads of people working on this. If you like go to Silicon Valley and you like hang out with startups, there'll be like hundreds. But I can send you a couple of names if you want to do a quick look. You can get deep research to do that.
Yeah, so maybe an idea would be able to point to like, oh, you know, here's this crazy agent doing all this stuff in the real world, and like it uses these complex systems.
Google co-scientist is like kind of interesting as well.
Yeah, I like it actually. All right. Thank you very much all for coming. Hope you enjoyed today's lecture.